Okay, so today we are going to do a problem appeared in the Apmo2024 in problem 1. So let triangle ABC be an acute triangle. Let D be a point on the side AB and E be a point on the side AC, such that lines BC and D are parallel. And let X be an interior point of BC ED. Suppose the ray is X, DX and EX meet side BC at points P and Q respectively, such that both P and Q lie between B and C. So, according to the parallel lines, we can have, for example, this angle equals to this angle, right? And let's continue. So suppose the circumcircles of the triangles BQX and CPX intersect at a point X different to Y different to X. Prove that the points AX, Y are collinear. So, talking about collinear, what methods do we have? Prove points collinear. The first method is if we have 3 points ABC, we have to prove that angle ABC equals to 90 degrees. And the second method, if we have the collinear points A, B, C, and we have E and F, like here, D and E. So we want to prove that angle ABE equals to angle CBD. That's the second. And the third, if we have one triangle and a cutting segment, a cutting line, we can use the converse of Mendelow's theorem. And the fourth one is if we have 2 circles with here, and here is the point. So we can solve the problem by using the radical axis. For now, what is the radical axis? I will explain it here. Radical axis is if there are 2 circles. If we have two circles, they are omega 1 and omega 2. So for the 2 circles, there are 2 intersections. If I say they are A and B, what is the radical axis? That is, if there is a point P satisfying the power of P to omega 1 equals to the power of P to omega 2. Then P is on the radical axis of omega 1 and omega 2. So that's the definition of the radical axis, and it is easy to prove that the radical axis is a line. It is a line, not a segment or array like this. So after having this, we can see if there are two intersected circles. For example, they here, like in this graph, if they intersect at 2 points A and B, it is easy to prove that the power of A to omega 1 equals to 0, right? And also the power of A to omega 2 also equals to 0. For B, it is actually the same. So A, B are on the radical axis of omega 1 and omega 2. And we can know that AB, it is line, AB is the radical axis. I will just use RA instead. So after knowing this, it is clear because for the four methods, if we try to prove that, if I will use the red pen, if we try to prove that the angle AYX here, if we try to prove that the angle AYX equals to 180 degrees, what should we do? We should try to prove that the angles AYD plus angle XYD equals to 180 degrees. But what is the connection between D, dy, and dx? So, and dA, of course. So it is not easy to deal with. And also for the second one, it is the same thing. And for the third one, you need to construct a triangle. Actually, here, if you want to construct one, you might need to extend one of the segments, for example, PY. But what is that intersection? How can we find the relationship or some information about this intersection point? Actually, it is hard to find that. So we finally choose to use the radical axis because we have already got the two circles and also intersected. So if we try to prove, so let's continue to the next. We still connect the points. We connect AY. So we try to prove that we try to prove that A is on XY, and also XY is the radical axis of, for example, they are omega 1 and omega 2. So if we want to prove that A is on the radical axis, we have to prove that the power of A to omega 1 equals to the power of A to omega 2, right? So what should we have? We should use the power of points. So we have to denote the points. For example, if here is S and if here is T, and what can we have? We can have the power of A to omega 1 equals to AS times AB, and the power of point A to omega 2 equals to AT times AC. So that's what we want. If that holds, so then we have AS times AB equals to AT times AC. Then AS over AT equals to AC over AB. Right. So after knowing this, what else can we continue to seek out? Like we have talked about before, like D is parallel to PQ, right? So we have these two angles of the same degrees, right? And also notice that if we connect the points SX, yeah, just here, for example, now we know that the cyclic PQXS is a cyclic quadrilateral. So we also have the angle PQX equals to the angle BSX, right? It is here. So we find that angle DEX equals to angle PQE equals to angle DSX. And then we can know that D, S, E, and X are concyclic. That is one thing. And in the same way, we can know that D, T, E, X are also concyclic. So we can know that the 5 points D, S, T, E, X are concyclic. So that's we've got. And if we draw out the circle, not accurate. So if there exists a circle passing through the 5 points, suppose it's here, and then what can we have? We can have the power of a to the circle. That is as times ad equals to at over ae. At times ae. So that means as over at equals to ae over ad. So what is the relationship between AC over AB and AE over AD? What is the relationship between that? Notice that DE is parallel to BC. So we can know that AD over AB equals to AE over AC. And that means AE over AD equals to AC over AD. So we can know that. So finally, we have proved this problem because we have got the power of omega 1 of a to omega 1 equals to the power of a to omega 2, right? So we have proved that a is on the radical axis of the two circles omega 1 and omega 2, plus xy is the radical axis of the two circles. Then a is on xy. So that means a, y, x are collinear. So that's the end of the proof. Thank you for watching.